An airplane with an unusual appearance, capable of flying high, far, and long. And that's not what's interesting about it. Before us is a bird asking a provocative question. How far away is the day when combat aviation will no longer need people? Hello aviators, Sky here, and today we are meeting one of the harbingers of the machine age. I present to you the RQ-4 Global Hawk. The Lockheed U-2 Dragon Lady is a vivid example of eternity of the temporary. Created back in the 1950s, it was considered a simple and cheap intermediate solution, but turned out to be unsinkable. The great paparazzi survived international scandals, super advanced Mach 3 reconnaissance aircraft and satellites, flying decade after decade. All this time, another story was developing: unmanned aerial vehicles. They were developing for a long time in many aviation companies, but remained exotic. Electronics, communications, and automation were not sufficiently advanced. Now unmanned vehicles are a recognized instrument of war and peace, but at that time, standing next to furious fighters and bombers, they seemed like toys, and their creators were considered something like aircraft modeling clubs. But by the 1990s, the picture started to change. Desert Storm had highlighted the need for extended communications and reconnaissance. The U-2 had performed well there, but was already hinting that it was becoming obsolete. And something more modern was on the horizon. Technology had advanced far, and a good computer with good communications could do all sorts of things, such as freeing a strategic reconnaissance aircraft from its main limitation. A pilot who, no matter how cool, could not sit in the cockpit for days. In a drone, this problem solved itself. Several companies took on the task, the main ones being Teledyne Ryan Aeronautical and Lockheed Martin. Ryan was one of those aircraft modeling clubs that had been working primarily on drones for decades. They quickly jumped on the bandwagon and developed their own concept called Tier 2+. They approached the military's idea simply. You want a U-2 without a pilot, we'll make you a U-2 without a pilot. The parents of the Dragon Lady presented a rather radical solution. Their project had the Tier 3 index and its own name, RQ-3 Dark Star. Not this Dark Star. The RQ-3 had an unusual design, a huge wing in the tail section of the flattened fuselage, which made it hardly noticeable on radars. It was the 1990s, stealth was everything. Both drones were developed with DARPA support and under secrecy. The Dark Star took off in the spring of 1996, the Tier 2+ in early 1998. Ironically, the quickly developed RQ-3 proved much more difficult to test. There were stability issues, and the altitude and range were rather modest. It was more of a stealth technical observer than a strategic reconnaissance aircraft. At first glance, Lockheed Martin's logic may seem odd. They were asked to do one thing and they did another. But they did not support the idea that the U-2 was obsolete and continued to modernize it. The Dark Star was seen as a complement rather than a replacement. The Tier 2+ was exactly what the military demanded: high altitude, long range, and most importantly, capable of flying for a very long time. While the U-2 could hang in the air for up to 12 hours of testing the pilot's endurance, the new drone promised more than a day, doing everything automatically on commands from the operator, who sat at the base in a comfortable chair and didn't even have to wear a spacesuit. By the end of the 1990s, Teledyne Ryan Aeronautical was acquired by the Northrop Grumman Corporation, who arrived just in time to acquire both the company and a very promising project. The tender was won, and the Tier 2+ received a new, already familiar name: the RQ-4 Global Hawk. The testing program involved 7 prototypes. They were actively flying and even participated in military maneuvers, testing new systems and expanding flight parameters. In parallel, the US Federal Aviation Administration participated in the project, looking to the future and trying to figure out how drones will share the sky with conventional aircraft. It seemed that several more years of work and the Global Hawk would be ready to go into service. But they didn't have several years. After September 11, 2001, the Pentagon called Northrop Grumman and demanded that all available RQ-4s be used in operations in Afghanistan and Iraq. At the same time, they were not particularly interested in whether the drones were ready for this or not. The result was, in general, obvious. On the one hand, the RQ-4, even with restrictions, turned out to be excellent reconnaissance aircraft. On the other hand, the number of problems was off the charts, and in a short period of time, several prototypes were lost. It is difficult to blame Northrop Grumman for this situation. What did you expect sending to war, frankly, unfinished machines? And the testing program continued under these conditions, with many delays and alterations. The Global Hawk was accepted into service only in 2011, already being, in fact, a veteran of several wars. All this time they were actively modernized, receiving new functionality and equipment. The design also changed, and at least once, quite radically. The RQ-4B Block 20 changed the design of some components, and also grew significantly in weight and dimensions. Now that we've gotten to the design, let's look at the Global Hawk from an engineering perspective. Usually, when people talk about drones, they imagine something small. This is not the case with the RQ-4. It is 14.5 meters long, and its wingspan is 39.9 meters. This is more than the wingspan of the Boeing 757. This layout is a direct legacy of the U-2 concept, but here the wing is more advanced due to its optimized design and extensive use of composites. The situation with high-lift devices is the same, only large 2-section spoilers plus 2-section ailerons. There are no slats or flaps. The tail unit is V-shaped. The fins are quite large and, with the design, work both vertically and horizontally. Simple and beautiful. The maximum takeoff weight reaches 14.6 tons, with an empty weight of only 6.7 tons. The absence of a pilot's cockpit, new materials and equipment did their job. The Global Hawk is noticeably lighter than the Dragon Lady. All of this is carried by a classic tricycle landing gear. None of the exotics from the U-2 with its bicycle landing gear and detachable wing crutches on wheels. By the way, one of the differences between the RQ-4B and RQ-4A is the different landing gear. On the original, the main gear is two-wheeled and retracts into the fuselage, while in the B version, the track is increased. The gears are single-wheeled and retract into small fairings in the wing. This freed up space in the fuselage, made the aircraft more stable on the ground, and ensured the flexible wing from touching the concrete. The fiery heart of the drone is a single Rolls-Royce Allison F-137 jet engine, a military version of the AE-3007 family of engines common among business jets. The thrust is 34 kilonewtons, which is half that of the U-2. Interesting, the RQ-4 is certainly lighter, but not very much, so it seems the designers are not eating their bread for nothing. The engine is located in a separate nacelle, raised above the fuselage in the tail section. A separate nacelle simplifies engine maintenance and frees up space in the fuselage. In addition, when scanned by radars from below, the air intake is hidden by the airframe, and the nozzle is hidden by the tail. No one tried to make the Global Hawk stealth, but they added a plus to its low visibility. The aircraft's flight performance varies. Cruising speed is 310 knots, service ceiling is 18,000 meters. Kind of boring, even the U-2 flies faster and higher. And now the advantages. The drone can stay in the air for up to 34 hours and fly the distance of up to 22,800 kilometers. With such duration, it can hang over the enemy's head for 24 hours straight, and the range is enough to fly from anywhere to anywhere on Earth. The Global Hawk ground infrastructure is divided into two elements. The mission control element, which controls the flight and execution of tasks, and the launch and recovery element. This is somewhat reminiscent of the spaceflight control network. The crew consists of 3 people, a takeoff and landing operator, a flight operator, and an operator of reconnaissance equipment sensors. Naturally, none of them are on board, everything is done from the ground. Then comes the balance of roles of the computer and the person. It is too early to talk about artificial intelligence here. The pilot is still needed, but his role is minimal. Automation does most of the work, and there are no virtual yokes here, only individual commands, like on space probes. Given the advanced communication systems, one should not be surprised by the geography. When a drone can monitor the Persian Gulf, its airfield is located somewhere in Europe, and the control centers are hidden at bases in the USA. The comparison of the Global Hawk to the space probe can be continued. By and large, it is a probe, also filled with a variety of research instruments. If we list all the instruments, we will get almost a complete list of optical and signals intelligence systems that the US has at its disposal, except perhaps in compact versions. It has optical and infrared cameras, capable of seeing an object the size of a tablet from a height of 20 kilometers, as well as a whole string of synthetic aperture radars of different ranges and an active electronically scanned array. Coupled with the high altitude of flights, they allow surveying huge territories. According to some statements, the drone can cover up to 100,000 square kilometers on one mission, which is an area the size of Hungary or South Korea. Most of the instruments are modular and can be replaced depending on the mission. The RQ-4 is equipped with inertial and satellite navigation, as well as a weather radar that constantly monitors the surrounding area. The communications complex is multi-channel, allowing large amounts of data to be transmitted in real time. The top of the communications complex is a large satellite dish, the fairing of which forms the distinctive whale hump in the nose section. An interesting nuance. Throughout the entire period of the RQ-4 project's development, there were proposals to equip the Global Hawk with weapons. And not as a simple attack drone, but as a component of a missile defense system intercepting ballistic missiles at the initial stage of their flight. They did not do this. The status of an armed combat vehicle greatly complicated legal freedoms during flights. Also, to perform the role of a missile defense system, it must approach the territories of a potential enemy in advance, which means protection not from a surprise attack, but from a retaliatory strike. This meant that the very fact of the drones appearing near the borders of some country could be regarded by it as preparation for an attack. And these are nervous times, so someone might accidentally press a button. The first serial RQ-4s were sent to reconnaissance aircraft bases in the United States, and eventually abroad. Naturally, the drone was and is actively working in the Middle East, Afghanistan and Libya. There's always a lot of work there. It is used not only as a reconnaissance aircraft, but also as a spotter and radio relay, significantly improving communications between ground troops and combat aviation. Of course, the Global Hawk, as the successor of the U-2, could not do without scandals. In June 2019, during a flight over the Persian Gulf, it was shot down by an Iranian air defense missile. There was a lot of noise, especially after the Iranians pulled the RQ-4 wreckage out of the water and demonstrated it publicly, like the USSR did in the 1960s, only at this time without a pilot. The controversial issue was the borders. The Iranians said that the drone entered their airspace. The Americans responded to this at first quite harshly, declaring that the drone was flying in an international zone and had the right to do so. President Trump wrote a threatening message on Twitter, and the Pentagon discussed a possible strike on Iran's air defense forces. But they decided to limit themselves to sanctions and cyber attacks. It can be considered that both got off easy. It's a pity about the Global Hawk, of course, but escalating could have cost much more. Spying on neighbors and targeting enemies was interrupted by humanitarian missions. The Global Hawks supervised the elimination of the consequences of natural disasters, such as typhoons and earthquakes, and man-made accidents, such as the accident at the Fukushima power plant. The seas were not letting up. The RQ-4's capabilities were tempting to the Navy, which was looking for a replacement for the aging P-3C Orion. Northrop Grumman, seeing this interest, quickly created a modification of the RQ-4N, later called the MQ-4C Triton. The modification was specific. A slightly different set of reconnaissance equipment is a given, but besides that, additional protection from an aggressive external environment, as well as a modified wing. The Global Hawk in cruise flew high, stable and smooth, but the sailors wanted the Triton to be able to quickly descend, survey sea targets from a height of several kilometers, and rise back. Such a roller coaster required a stronger wing. The Triton does not work from aircraft carriers. Don't get your hopes up. Modernization of the drone to Block 30 and Block 40 versions did their job. Operational efficiency increased significantly, initial issues were solved, and technical maintenance was more or less put in order. By 2015, statistics showed that after returning to base, the RQ-4 could be prepared for a new mission in less than 5 hours. The usual work schedule: takeoff, entry into the observation area a couple of thousand kilometers from the base, the actual patrol, which can last about 24 hours, and then back home. But despite all the successes, the RQ-4 had many problems, and most of them were economic. Because of work trips, the project was delayed, and expenses increased significantly. In addition, they were being produced one by one. During all this time, less than 100 RQ-4s were made, which also didn't allow to save money on production scale. The result was painful. While in the beginning of the program in 1994, the cost of the drone was estimated at $10 million, by 2013 it was already under $130 million. $10 million for such a machine is of course too optimistic an estimate, but 130 is a fully equipped brand new fighter. Have you no shame? This led to an ironic situation. The RQ-4 was supposed to become a more effective, reliable, and cheap replacement for the U-2. But by the time it was adopted into service, it turned out to be more complex, problematic, and expensive. And while at the beginning of the century, many were waiting for a replacement of a manned aircraft with a drone, now you can argue about which of them will serve longer. Lockheed Martin, betting on the Dragon Lady, may have had the right guess. The obvious consequence of this was a cooling of demand. The Pentagon limiting budgets reduced the volume of orders for the Global Hawk. At the same time, new roles are being sought for the drone. For example, within the framework of the Range Hawk program, existing devices are to be modified to monitor ballistic missile tests. Curiously, demand for the sea-based Tritons turned out to be greater. Perhaps it is a matter of better adaptation to the vast areas of the sea, or perhaps someone assumes that the main battles of the future will take place at sea, and electronic eyes are needed there more. In the fight for their machine, Northrop Grumman was looking for alternative demand. Fortunately, the potential of the RQ-4 was appreciated not only by the American military. NASA participated in the development of the project from the very beginning, and after the completion of the first series of tests, they managed to grab a couple of prototypes that are involved in many research programs. Exports also promised to be good. The drone quickly attracted interest in many US allied countries that could afford such a toy. Not everywhere the negotiations ended with contracts being signed. The project encountered technical, political, and bureaucratic obstacles, but in some places they were overcome. There were no epic order portfolios, but limited purchases did appear. In our time, given the situation on the world stage, the Global Hawk has a lot of work. From the seas off the borders of Taiwan and North Korea, to the hot skies of the Middle East and Ukraine. In the era of modern confrontations of high-precision systems, these unarmed guys are a more dangerous weapon than some fighters and bombers. It would be better if they monitored the weather and chased solar eclipses, but the world is what it is. Comment what you think about the electronic eye in the sky, and subscribe to the channel. Fast flights on, for now, manned aircraft, and soft landings to you.